welcome back. Another exciting video here at Blue Glow Electronics. Today on the bench we got a Scott Stereo Master 299D in really nice shape too. Nice wood grain cabinet. You know, the only flaws I can even see to it is got a little bit of a scratch right up here and a teeny little scratch here across the faceplate. All original knobs. They certainly need cleaning, but apparently the guy that owns this wants it going through. Didn't want to spend a ton on it, as in not a deep full restoration per se, but just wanted to get it running good and solid, something to last for years to come. So we're going to dive into this thing, get the guy a quote, hopefully hear back from him, and then we'll kind of take it from there. Got the cover off of it, in pretty nice shape. Got the original tube shields here, which is a good thing. Looks like some pretty decent tubes in it here. We're going to have to pull them all and test them, but they're intact. They're not broken, or I don't see any white gassy tubes in here. Might go put it on the bench and see what it's doing, whether it's working or not. I didn't get a lot of details. A lot of the stuff comes to me via middleman, so somebody knows somebody and they ask, hey, could you drop this thing off with this guy? And by the time I get the info, it's not always precise, or they don't have a lot of details. So I think that might be what I do with it next here. Let's get a little lesson here in removing the bottom cover of amplifiers. A lot of people would remove this cover and kind of set it aside and not take a look at it, but there's a lot of telltale signs on the bottom of an amplifier cover. And if you'll notice here, nice little place here where a power transformer sits. You can see the shape of it, but you can tell what's happened. Something near it has leaked like crazy and actually ran down under and sat there, and you can see it ran all on the sides here. And so if you come over here and you trace, you know, there's really nothing to leak out of a power transformer unless it overheats and a little bit of the tar comes out, and that doesn't look like tar. So you kind of then start saying, okay, what has done the leaking here then that is all over the place? And so you kind of just lay it along here. And what you come to realize is that this capacitor down in here, you can see, has leaked like crazy. Additionally, here I'm finding a coupling cap here that is pretty much fried all two pieces and burned in half. Can you see what I'm talking about? It was actually even a plastic cap, and I didn't mention this to you, but when I was removing the the top case, these two pieces fell out. And I kind of knew what they were, but I thought we'd get to this point to see it. But these are actually parts, you know, the plastic outer of this capacitor here. So this thing definitely needs a recap job, that's for sure. And definitely this capacitor here replaced, you know, potentially more. But it, you know, all in all, it's not in horrible shape. It's got all its original coupling caps in this thing. And you know, not too bad. We're gonna probably not gonna put it on the bench and power it up after what I've seen here after removing the cover. It's pretty evident that this cap is completely gone, and this one as well, and definitely would always replace these two here, part of the bias chain. Whether we replace all these coupling capacitors in here, I'm going to leave that up to the owner, whether they want to spend the money on that or not. They very well may be good, but at the same time, these things could be starting to leak down. I'll give him a quote and see what he kind of says based on that. Just a few things to note I found of interest here. I thought I'd point out to you. One, the key on the bottom of this tube is broken. As I wiggle that, it kind of moves around. That's not a big deal. The tube could very well still be fine and functioning fine. Second thing I found is that hidden down inside here, a little bit tough to see, but is there a Siemens bridge rectifier. And these things are notorious, from what I've been reading on the forums, about going out. So I'm going to replace that with a modern day bridge rectifier. This bridge rectifier feeds off of these orange wires that feed over here, and ultimately they come off of this set of orange wires coming out of the transformer. And what they do is they establish a 48 volt circuit here that ultimately then goes across these 4 tubes here. So they're the DC providing heaters, providing voltage to your heaters and your tubes here on the front end. So it's kind of 12, 12, 12, 12, and that gives you your 48 volts across there. The next thing it does is it also feeds over here to the bias circuit here and feeds your bias on the output tubes here. So it's very important that that circuit is correct and that it's putting out the right amount of voltage, or otherwise you get some maybe runaway 7591s back here, which is not good. Or you end up with burning up the filaments here on these front end 4 tubes. So I'll pay special attention when I replace that to see, did it change the voltage designed across these. I may end up having to change a resistor or 2 in here to get the exact right voltage. But the other thing I've been noticing, just these 0.1 microfarad capacitors here, here, and here. There's a set of 8 of them. Definitely going to replace those. They're the coupling capacitors between the various stages, and it's just dangerous to leave those things in there with the age they have on them. The DC setup on this set of tubes, it gets fed over here, and theoretically it gets blocked right here, and only allows the AC signal, the audio, to go through to the output tubes over here. Well, if these things are leaky and letting DC through, then it changes the bias on typically the input grids of these things, and causes some really bad scenarios. So definitely going to look at least these here, and then I will talk to the owner about all these other capacitors. All these others are more tone capacitors. They're not direct audio path between the front end and the back end per se. Just what I've been noticing so far. Gonna figure out. Oh yeah, one more thing to figure out. This multi-section cap right here. It's got 2 sections to it. Both are with 30 microfarad at 500 volts. So if you know anything about modern day capacitors, 30 microfarad is not a standard value, and 500 volt capacitors are not easy to come by. So gonna have to figure out what I put in place right there. Hang tight, and we'll keep rolling with this thing. I got to get an email off to the owner and see what they're wanting to do with this thing and how far into it they're wanting to go, and give them a rough price estimate of what I'm looking at here. Okay, we used a pair of cutters here to get the band off that holds the rectifier in, and once you kind of break it through, then you can pull it up like this, and you can see which connections need to go to what, so that we can replace this thing. The original rectifier was a B60C200 selenium rectifier bridge. If you'll notice, this thing, even though it's larger than the one I'm going to put in it, this thing was only rated at 60 volts, 200 milliamps. Let me show you what I'm going to replace it with. It is a GPU 6K, which is it's basically, here if you look at it, it's a 6 amp continuous 175 amp peak, but it's intended to operate up to 800 volts or whatnot, so this thing should work well in its place. It's quite funny, this thing being selenium, and seeing what the current solid state, the solid state's smaller and only about half as thick, and what I'm going to end up doing is splicing these wires onto these leads and mounting this down in here using one of these holes from the inside, and we'll have a nice neat little package to replace this selenium that needs to go. And if you notice, I'm cutting these leads off just to make them a little shorter as we go to mount them. And what I'm going to do is strip each one of these, put some heat shrink up over it, solder it on there, and drop the heat shrink down. As you can see here, we've got the first one soldered on, and I put the piece of heat shrink tubing up on it, waiting on it to cool down a little bit, and we'll slide that down over top here, and then heat it up with the gun. And as you can see, got it all sealed up nice and neat. We'll just mount that against the wall here and probably throw a little bit of heat sink grease on it and mount it up there so it'll never come loose, and you can dissipate a little heat against this aluminum frame. But simple replacement. And as you can see, nice and neatly mounted down here. Got the screw coming through, bolt head on the other side, a little bit of heat sink compound, routed the wires nice and neat back up to where they originally came from. And we have officially replaced the somewhat dangerous and prone to die selenium rectifier bridge here. As you can see here, I've basically removed two of these. They were sitting right here and right here. I've removed them and started replacing them with the poly caps. Didn't choose to go with high-end caps on this one, just mainly because the customer wanted to get it up and running and not invest a ton in it. Was trying to get out as economical as possible, and these will sound great for what they are and for what they cost. As you can see, I've got all four of these replaced, all four of these replaced. I'm going to replace these two electrolytics here, as well as this capacitor that's burned up really bad right here. These are 4 microfarad at 250 volts. I've got some 4.7s at 450 volts, some Rubicons that I'm going to use right here. And this one was a 50 at 75 volts, and what I've got here is a 47 microfarad at 250 volts. Alright, we got the 47 microfarad in here and the two 4.7s in here. Looking pretty good so far. I'm waiting on some parts to show up. I had to order some 33 microfarad capacitors that'll go right here at 400 and I think we're at 500 volts. As soon as those show up, we'll get the rest of this thing wrapped up. This is 30 microfarad capacitor here. If you'll notice, what it did have was a resistor across these two here, kind of for balancing and discharge. And then it had two wires running over here. One, there's red wire here coming down to this connection, and this white wire here coming down to this connection. We're going to have to take a look at a few other pieces here. So the outer tab on this is not actually at ground. So what I'm going to end up doing here is I've taken two, just happened to find these in a box I had, two 30 microfarad 600 volts, which is good, capacitors. I've put the resistor across them already on the positive leads. The negative leads here I've tied together on the back end, but these things are not going to fit in here very well. But yet I found a nice spot back here. I think they will fit. So I'm going to look at rerouting these two wires back to here, and then running a wire from the negative post over here as well. And after studying a little more, I really can't even get that thing to fit well back in this space. So I've looked online and broke down and ordered a new capacitor here that'll go in the top with a new bracket that'll hold it, much like used in some of the Fender guitar amplifiers. I think it'll be a 32 microfarad. A little bit pricey, but I believe it's what's going to be required. Yeah, it's been a few weeks since I've touched this amplifier. I've had a bunch of other stuff on and off the bench in the meantime, but I was waiting on some parts to show up. So if you remember where we last left off, we were looking at replacing this capacitor, and I was trying to use some just some internal capacitors of some type and mount them over here, but never could find a good mounting spot for them. So I went ahead and broke down and ordered some new capacitors. I'll show you that in a minute. But one thing I wanted to show you, a couple things about this capacitor of importance to note. First off, if you'll notice, none of these lugs, these ground lugs right here, nor the actual positive connections to the capacitor, the two different ones, nor this ground lug, nor this one, nor this one. All four of these, which go actually to the outside of the can. None of those are actually chassis ground. If you'll notice that, it's got this little wafer here that when you mount it keeps it separated, so that chassis ground is separate from the actual capacitor ground here. So in knowing that, I went ahead and did this. When I disconnected the wires here, if you'll notice, I labeled that as a positive and a positive, those two wires, and then all of these, if you'll notice, I labeled them, they say can ground on them right here. But you've actually got 4 wires here that have got to hook back up now to what on the new capacitor will be a single lug. Let me show you that real quick. So right here, what we've got, this is what I'm going to replace it with. It's a 3232 at 500 volts. Pretty solid capacitors. Got this from Antique Electronics Supply. They're about $8, and these things are really, really solid. Used them in many guitar amplifiers before. And if you'll notice here, it's got one of the little tabs on it has a black colored post on it. You notice the others are both silver. And so this is the ground, and this is 32 microfarads, and that's 32 microfarads. Basically 2 capacitors in parallel right here. So what we're going to have to do is this ground lug right here. All 4 of these wires here that were connected to ground of the chassis of the capacitor are going to end up going to this ground lug, and then one of these will go to the 32, and this will go to the other 32. What I'm going to do is I'm going to take this over into the workshop, and if you can see here, it's got a little rivet right here and a rivet right here. I'll end up drilling both of those rivets out. That thing will drop down. I will end up putting a one of these mounts, and I'll mount it below the chassis down here like this, and then this capacitor will actually slide inside of that. And if you'll notice, the capacitor has a plastic covering on it here on the outside, so it would then isolate the capacitor from ground at that point, and I'll be able to just solder these things up, and like I say, this capacitor will push up through the top once I get that drilled out. But it should turn out pretty well. Hold tight, and we'll be back with it in just a little bit. Alright, the whole key to drilling these things out is you need to get a drill bit that's larger than the actual rivet you're trying to drill out here. Because what you really just want to do is, like on a rivet like this, you just want to cut the head off of it. Most of these things are aluminum, so it doesn't take much at all. I basically took the drill here, made sure all the wires were out of the way, and just went down here and down here. And this dropped right out the bottom then. And you can see here the tops of the rivets are still there. All I've done is cut the heads off of them a little bit, and this thing's out of the way now. So just need to get a little bit of vacuum going on in there, and we'll get that thing out, or get the little metal shavings out, and we'll be ready to mount the chassis. And as you can see, I've got the capacitor mounted in here. Went ahead and tightened it down, and I turned it so that the little black negative connection faces the majority of the wires that I've got to connect. And this thing should, at that point, just kind of drop down in through that hole and mount down in there. Alright, one thing I wanted to show you. This capacitor was designed to fit in this hole, right? However, the plastic covering on this thing, the tolerances were so tight on this thing that the plastic covering on this capacitor was keeping it from dropping down in there. So I had to use just a little, what do they call this thing? I'll think of it about the time I put the camera down, but basically designed to deburr, deburring tool, that's it, to get the burrs off. And I just went around a few times. It created a few metal shavings down here, as you can see. Basically just open this up just the slightest little bit, so that now this capacitor can drop down in there. Okay, as far as mounting screws, I've got some, these is interesting. I actually bought this bag years ago. It was, they were Dynaco ST70 screws. Somebody had a whole huge lot of 1,000 of them for sale, and I've used many of them over the years. And what I did was ordered some 6/32 nuts with the built-in lock washers on them, and I've been using these things for years. So let's see, I got a bunch of lock washers too, but they work great for lots of small mounting purposes like this. Let's get this thing mounted. And as you can see, there's not a ton of clearance here in the bottom, but we've got it mounted now. Nice clean screw there, nice clean screw there. Held in place really tight. You know, check the tolerances between like where this the head of this thing is and the next capacitor and all. We're good. And then I always like to you know, kind of run a ruler across and lay it flat on the chassis. And you can see here I got about a 1/4 inch clearance there, so I'm feeling pretty good about that as well. Okay, I'm pretty happy with the way it turned out. The capacitor's in there really snug. Everything's tightened down. I've checked to make sure these wires will reach over everywhere we need them to, and we're going to be good there. Let me flip it over and show you what this thing looks like on the other side. Okay, as you can see, it's just mounted down in here with the other capacitors. I could have put that mounting bracket up here on the top side and given myself a little more clearance, but I think it just gives it a good clean look here to have that mounted in here like that. So I'm feeling pretty good about it at this point. And as you can see, I've got the 4 wires ran here, all inside the hole in the black lead here, the negative, and I've got all the wires wrapped around really good. Similarly here, kind of ran the wires in here and wrapped them around so they're good and tight. They're being held in here mechanically and not just by the solder. And now we're going to solder these things up. Okay, we're all soldered in. Good now. I've been getting some emails or messages on YouTube asking about soldering, and there's tons of videos out there about soldering, but people were saying, okay, we get that, but what are you using to do your soldering with? Oh yeah, one more thing I got to remember, there's a bleeder resistor that goes across these things that I've got to put back in here. But just, you know, real quick, I use a Heiko, I think this is the FX888D. Thing runs about, I don't know, 90 bucks or so. You can get them on Amazon, you can get them on eBay. Nice digital unit. I run mine at 750 degrees for most any point-to-point wiring like this. You know, if I'm working with circuit boards, small trace stuff, I'll drop the temperature down some. I use the standard, it's a screwdriver tip here on the end of this thing, nothing special. Use a sponge down here. We'll give you a tip on these sponges when your original Heiko sponge wears out. Go to the grocery store and buy some kitchen sponges and cut and make your own. These things are about 2 for $1, and you'll get 4 out of a pack for $1 versus the $11 that Heiko wants for a new one. And I really use 2 sizes of solder here in the shop. The first one here, as you can see, is a 0.062 diameter or 16 gauge, pretty big stuff, and I use this for all my point-to-point, like I used it to put the solder on here. It is, if you can see here, it's 63% tin, 37% lead. That's what I like to use, and this is by MG Chemicals. That's pretty big spool there. The other size that I use here, as you can see, I think it's a 0.03. Can't read it now, but like 0.035 or something like that. And it again is 6337, and if you'll notice, this is from Alpha Metals. It's pretty good solder, but it's the same thing, just much smaller in size. And I use this for when I'm working on circuit boards or maybe more tedious stuff than some of this bigger point-to-point stuff. But I'm constantly swapping back and forth between those. But that should answer the questions that people have been asking me about what I specifically use here. Alright, the original resistor that went across these two right here, it was a 270 ohm, about a 3 watt resistor. And I looked and I didn't have one, but I did have the original. It was just too big to go across here. So all I did was follow these wires down to where they connect to the next location. As you can see, one connected here on this post and one connected here on this post. And I mounted that 270 ohm resistor up to this post and soldered a little piece of Teflon wire over here to the other side, and that thing is solid as a rock, not going anywhere. And we've basically jumped across those same 2 spaces that we've got right here. Just did it down here instead, and it'll work out just fine. One last thing I want to do here before I power it up and test things out. Good old CL80 thermistor. What these things do is they basically, you put them on the input one of the power leads will go in here and the other will feed out here. You're just basically putting in series with the power line here. And what it does is it's kind of a slow start device, so it lets the voltage in this thing build up a little bit slowly. One, that helps with the filaments. Two, the other thing it does is it drops some voltage. I want to say it's around 1 volt or maybe 1.5 volts that this thing will drop on the input, which helps a little bit with today's modern power supplies, wall outlets, because these things were designed to run, you know, at 110, and most common wall outlets today put out around 115. So I always put one of these in every amplifier. The slow start helps a lot. So, you know, here on the power fuse holder, I've got 2 wires feeding into it. I'm just going to disconnect one of the fuse wires there, mount this thing, put it in series, and we'll be good to go. As you can see, I usually snip the leads off. I leave just enough here to get a good solder connection, and I bent these things so they're kind of in parallel, I mean in series there. And then I'm going to come right off the fuse holder here, and I'll keep this thing flat so it doesn't get in the way of the, you know, plenty of chassis clearance. And on the other side, I'll connect the wire where this one was originally connected. As you can see now, I've got one end soldered really well to the fuse holder lug here. The other end I soldered onto the wire that originally was connected to that feeds into, up and around into the transformer. And I've put a little bit of heat shrink tubing on here just to, since there was a good bit of exposed right there wire. So we should be good to go now. That thing's mounted. I always look out for things like clearance on holes like this, because you notice the cabinet's got a mount right here. So if I'd have mounted that thing back just a little bit, when they would, you know, when somebody would have tightened down the screw here, it would have went into the thermistor. So always look out for hole clearances and whatnot as you mount things like this. And the last thing, I've been waiting on these to show up. I was out of the 0.047 microfarads and the polycaps, and we got some that showed up here, and I'm going to get 2 of those mounted in here to replace these 2 things, and I think we'll be ready to turn this thing on and check it out at that point. Alright, they have both been replaced now, and we're going to put some output tubes in this thing, the rectifier tube, bring it up and see what it's starting to measure out at. And as you can see here, I've my test leads coming from the audio analyzer and dummy load and whatnot. I've ran down here and connected, but I was getting ready to connect up the wires here for my iPhone to play through the extra slot, and I noticed these things are pretty ugly. So you've seen me do this in other videos likely, but it's a kind of a forward-facing brass brush, and I mount it on a Dremel. Turn that thing on, and you know, kind of go to town here on getting the old crud and oxidation off these things. I'm just doing it left-handed here, give you an idea, but I'm going to drop the camera and clean these things up. Alright, you can see I've got my RCA jacks connected up, and I've got the tubes put in this thing. You can see underneath here the 5AR4 and the 7591s. And so when I flip it over, I've got this board here, because if you don't put something here on the back side to prop it up, it's just a 2x4, then your tubes here will touch the ground, and it's not what you want. So got it mounted up, and gonna bring this thing up slowly on the variac and start checking some voltages. One of the voltages that I'm most interested in seeing if it's right or wrong, if you remember, we replaced the selenium rectifier right here with a modern solid state silicon rectifier, and it has less voltage drop on it than that selenium did. And that voltage regulator feeds these wires here that ultimately feed into this little power supply here, and then it goes to the tubes on the front here and provides does 2 things. Provides 48 volts across these 4 tubes here, so it's kind of 12 volts, 12 volts, 12 volts, 12 volts for the filaments, but it also supplies a negative 48 volts for the bias circuit here. So I'm going to want to make sure I get the right voltages or, you know, the negative 48 volts here. Let's say it was at 52 volts or something. Then I'll probably have to increase a resistor somewhere along the way here to help offset a little bit and get these voltages in range. Otherwise, you're driving the negative bias on these output tubes too much on the grid, and can cause the tube to overconduct there, or be too hot. So we're gonna check all that out as I bring it up slowly. Okay, we got the Variac slowly up to about 100, and we're sitting at 119.8 volts right now. And you know, I slowly brought this thing up somewhere around 85 volts is where it started. I could start hearing music a little bit, but so I'm going to go through the rigmarole of you know, checking this thing out on the audio analyzer, and checking distortion and spectrum analyzer for any erroneous stuff. But so far so good. Continue checking it out. I do want to get in here and check the bias voltages next.
So many mothers dying. News had just come over. We had 5 years left to cry. This guy wept and told us was really dying.
Things sound really good. Thought I'd play a little David Bowie tribute there. I've got the bias set on this thing. There's a couple different ways to go about that, but I didn't want to go modifying this thing too much. One way is you can go replace all these 3.3K resistors and from the cathodes, and put like a 10 ohm resistor to ground, and then you know, rebias each tube that way. But kind of the factory way to go about it. It's got a couple test points. You should be getting like right here on these. Should be getting 0.23 volts right here, and these two pots right here will adjust that right and left. And then similarly on pin 5, you should be getting 0.85 negative volts on each one, and these two pots left and right will adjust that. And we've got this thing set at this point in time, so kind of follow the factory schematic setup for that. Some people will go in and modify these things though, so that they can kind of take a direct reading of the output, you know, kind of cathode current, which ultimately is the same as the plate current in this thing. So I was having a little bit of an issue. When I got it up here on the audio analyzer, I was feeding into it, or out of it, and I was reading into a dummy load, and then on the oscilloscope here. And what I was getting was one channel had about 0.5 volts peak to peak out at the setting I had it at, and the other side had about 0.7, so it wasn't balanced. So I went and pulled the 4 tubes in the front end of this thing out, and went and tested them, and sure enough I had missed one that was off balance, so put a new tube in there, and let me show you what I got now. Okay, at this point I'm basically getting a 0.5 volts on both sides, no matter which side of the channel I flip it to, and I'm feeding in right now at let's see, amplitude 0.3 volts, and that'll drive it on up there a little harder. Yeah, we can cut that down, but let's see what we're getting here. Distortion wise right now, and I'm driving it pretty hard right now, 0.28 percent distortion, which is an extremely low number. I'm really happy with that. If I go to the other channel on the distortion, a little bit more distortion on the other channel. I may get a little bit more testing on the tubes in this thing. And I cleaned all the tube socket pins, or the pin sockets, really well. Now I'm getting pretty much the same setting on either side there, around 0.3 percent distortion, and that's cranked up pretty loud. I mean, you can see the volume knob here. I've got it on 9 right now, so I mean, I could go just slightly higher here, almost to a 10 there, and it jumps up to the 0.385. So don't ever overlook cleaning pin sockets, tube pin sockets in an amplifier like this when you're trying to get rid of some distortion or whatnot. It's amazing what just a little bit of corrosion inside of one of those things will do. This thing's performing well right now. You can check the harmonics on it as well. If you notice, I've got everything set here on dummy low. If I flip down here to speaker, you would certainly hear it. And jump up here on the spectrum analyzer, and lo and behold, give me 1 second here, let me jump. Yeah, I mean, even with this thing way up here, you can see there's just barely little blips here at the 0.3, 0.5, right there, and 7, a little bitty dip down here at 9. At any rate, that's, you can see really no harmonics to speak of whatsoever on this thing. I flipped to the other channel just now, same thing, little or nothing here. So really nice and clean. Interesting on this one, I'm getting a little bit of even harmonics here as well, but just a teeniest little blip, nothing to even measure. Alright, things sounding great. I was just noticing that this light here on the front was a lot brighter than this one. This is supposed to indicate right channel, left channel. So like if you go left balance here, right balance, mono's there both, stereo drops the middle one out, reverse input, left, right. But if you notice, the right one here is brighter than the left one here. I'm going to see if I can get in here and fix that. To do that, I basically removed 2 screws here on this side, 2 screws on this side, one down here in the middle, and this metal cover here just came off. And I can already see why one's lighter than the other. Let me spin it around here and I'll show you. See if you can figure it out. If you'll notice, this thing here is pushed back a good little bit from this one. The way these do, they have an NE2 little neon bulb in there, and then there's a maybe you can see it under a black piece of like cloth connector there of some sort, tubing that goes up and feeds the lights. And this one's somehow over time gotten pushed back, and so we'll fix that. I'm gonna go fix it real quick. Alright, check it out. Sounding amazing. Got the lights fixed now. That's all it took was, you can see the left one and the right one, they're equal now. stereo sounding great. Sometimes it's, you know, it's the little stuff like that that makes a big difference in a restoration. A lot of people may not have even paid attention to that, but I'm an attention to detail kind of guy. So everybody, I hope you've learned something today. You know, I went fast on a few of the steps just because this video is getting pretty long, and you know, I've shown it before. I mean, like the bias on this is pretty much the exact same as on the 222Cs that I've shown. So I went pretty fast on that. But if anybody's got any questions, just reach out. Be glad to answer them. Really appreciate everybody watching. Got some really cool projects in the work right now, I can tell you that. I'm really cutting back on the amount of repair work that I'm taking in, because I'm trying to get the shop cleaned out. I've got a few things I'm wanting to build from scratch and kind of bring forward, so hopefully you'll get to follow that along as well. So thing just sounds amazing.
I went down standing man. I want 6 craft shooters be my pallbearer. Give me a chorus, girl, sing me a song. Put a jazz band up on my hearse wagon. Raise my sand while
Oh yeah, I was going to show you a couple more things as I wrap up. I had the original manual up over here earlier when I was getting the bias readings and whatnot, but check it out. Maximum harmonic distorted at rated output, 0.8% distortion. So we're within specs of this thing from the original manual here. I don't know about you guys, but I don't think that capacitor looks bad in there at all. Really happy with how that, you know, turned out being mounted in there in original spot and whatnot. Got the tubes back on, got the two covers back on, got this cover back on here on the back, and you can see now both lights are just as bright as can be. I'm really happy with it. We're going to get the big cover back on this thing. I'll let you see what it looks like, and then wrap this thing up. If you remember that whole attention to detail thing a while ago, I was carrying it over here to the other side to put it on the workbench and put the cover back on it. And I noticed this little beauty ring here on the back is a little bit loose, coming off here on this base knob. So I use this stuff here at Bob Smith Industries. You can pick it up at Hobby Lobby, or you can order it on Amazon. It's quick epoxy, 5-minute cure, pretty good sized bottles for about $10. And we'll mix up 2 different drops, stir it up here, get enough, and put it on there. As you can see, 2 different drops here. I put 1 from each side. Then you just got to stir this stuff together, mix it up, and put the camera down. But get enough on here to just put just a tiniest little bit on the back side of this knob, so when I push that on there, it'll stay glued. Okay, I just used the screwdriver, applied the tiniest little bit on the back of that ring, slid it over there. Then I just used a paper towel here, and I got off any excess going around it, and things looking amazing now. In 5 minutes that thing will be glued on there hard as a rock, and nothing to worry about. I always like to pull on these things just a little bit just to see if they're about ready to come off, but all those seem to be pretty good. Let's get the cover on it. Last little epoxy tip of the day. I always use a Post-it note pad, because when you peel that off, then you throw that away, you've got rid of all the goop, no cleanup, and you still got your little Post-it note pad then, so it makes cleanup really easy. That's what I use for that. And we're right back to where we started. If you'll notice, look at that big old pile. I mean, that stuff's thick. That was what it leaked out of that capacitor on the bottom plate. So I'm going to take it over here to the grinder and use the wire brush to get all this stuff off. And as you can see with the wire wheel, I got it all off. A little shiny in spots, but better than being corroded in spots. I had to get into it a little bit here to get some of the corrosion off, but at least that way it won't keep eating away at the aluminum over time. There she is in all her glory. Nicely mounted in the chassis here. Got feet underneath of it. Lots of air and ventilation for these tubes here on the back end. Really happy with how this thing turned out, and I hope everybody enjoyed the video. Keep watching, we'll keep making them, keep giving me feedback, we'll keep improving, and kind of take it from there. Thanks everyone.